Today, we are going to talk about polynomials. Now, what are our expectations? First, we need to define a polynomial expression and familiarize it with its standard form. And then second, divide polynomial expressions using the long division method. Let's have a review on factoring methods. Here are some factoring techniques. We have common monomial factoring. Common monomial factoring is also called common factoring. A common monomial factor is a monomial that is a common factor to all of the terms of a polynomial. xy plus xz is equal to x times y plus z. The common factor is x. Let's have another example. We have 5x minus 25. So what will be the factor of 5x minus 25? First, you need to find the GCF or the greatest common factor. So what is the greatest common factor? Yes, the greatest common factor of 5x and 25 is 5. And now, you need to divide the GCF to both terms, which is 5x divided by 5 and 25 divided by 5. So 5x divided by 5 is equal to x, and negative 25 divided by 5 is negative 5. So the quotient is x minus 5. Now, the complete factor is the product of the GCF and the resulting quotient. So therefore, 5x minus 25 equals, the GCF is 5 and the quotient is x minus 5. So therefore, the common factor or the complete factor of 5x minus 25 is 5 times x minus 5. Next, now, what about 6x cubed plus 9x squared minus 6x? What is the greatest common factor? Okay, correct. The greatest common factor is 3x. Now, divide 3x to all of the given terms. So 6x cubed divided by 3x, 9x squared divided by 3x, and negative 6x divided by 3x. When we divide 6x cubed divided by 3x, the answer is 2x squared. And 9x squared divided by 3x, the answer is 3x. And negative 6x divided by 3x, the answer is negative 2. So the complete factors of 6x cubed plus 9x squared minus 6x is equal to 3x times 2x squared plus 3x minus 2. Another factoring techniques, we have the difference of two squares. The difference of two squares is expressed in the form x squared minus y squared. Since this is a special product of the sum and difference of a binomial, so we have x plus y times the quantity of x minus y. Therefore, the factor of x squared minus y squared is equal to x plus y times x minus y. We have here an example, x squared minus 9. If you are going to look at the example, x squared and 9 is a perfect square. So for the solution, you have to separate it by plus and minus sign, and then get the square root of x squared and the square root of 9. The square root of x squared is x, and the square root of 9 is 3. So therefore, the factor of x squared minus 9 is equal to the quantity of x plus 3 times the quantity of x minus 3. Another example, we have 4x squared minus 25. Again, if you are going to look at the given terms, 4x squared and 25 is a perfect square. So what will you do? Again, separate it by a plus and minus sign, and then get the square root of 4x squared and the square root of 25. So the square root of 4x squared is 2x, and the square root of 25 is 5. So therefore, the factors of 4x squared minus 25 is equal to 2x plus 5 times the quantity of 2x minus 5. Another factoring technique is a perfect trinomial square. Perfect trinomial square is expressed in the form x squared plus minus 2xy plus y squared. Now, this is also a special product of the square of a binomial. So therefore, it is x plus minus y squared. Now, the factor of x squared plus minus 2xy plus y squared is equal to the square of x plus minus y. Now, let's have an example. We have x squared plus 6x plus 9. Now, if you're going to look at the first term, x squared, and the last term, 9, both of them are perfect square. So, since it is a perfect square, and the middle term is twice the product of the square roots of the first and last term, so we have, now since it is positive, so we need to write all positive. So the square root of x squared and the square root of 9 is equal to x plus 3. So therefore, the factor of x squared plus 6x plus 9 is equal to the quantity of x plus 3 squared. Another, we have here x squared minus 10x plus 25. Again, if you are going to look at the first term, x squared, and the last term, 25, both of them are perfect square. Now, since the middle term is a negative number, so you need to write all factors negative. So, get the square root of x squared and the square root of 25. The square root of x squared is x, and the square root of 25 is 5. So, therefore, the answer is x minus 5 squared. Another set of factoring, we have sum or difference of two cubes. So we have x cubed plus y cubed is equal to x plus y times the quantity of x squared minus xy plus y squared. Or x cubed minus y cubed is equal to x minus y times the quantity of x squared plus xy plus y squared. Now another quadratic trinomial. So let's say x squared minus 5x plus 6. So the factors are x minus 3 times the quantity of x minus 2. And then we have also the grouping method. So the example is x cubed minus x squared plus 2x minus 2. You have to group first x cubed minus x squared and another group 2x minus 2. Then get the greatest common factor of x cubed minus x squared, so that is x squared. So x cubed divided by x squared is x, and x squared divided by x squared is 1. And for 2x minus 2, the GCF is 2. So 2x divided by 2 is equal to x, and 2 divided by 2 is equal to 1. Now, as you notice, they have the same factor, which is x minus 1 and x minus 1. So, get x squared plus 2 in a given factor and another factor x minus 1. So therefore, the factor of x cubed minus x squared plus 2x minus 2 is equal to x squared plus 2 times the quantity of x minus 1. Let us discuss polynomial expressions. What is a polynomial expression? It is an expression of the form a sub n times x raised to n plus a sub n minus 1 times x raised to n minus 1 plus a sub n minus 2 times x raised to n minus 2 plus x sub 1 times x plus a sub 0, where a sub n is not equal to 0. N must be greater than 0, and n is the degree of the polynomial. Therefore, it must always be a positive whole number. A sub 0, a sub 1, a sub n minus 2, a sub n minus 1, and a sub n are real numbers. Now we have here a sub n times x sub n plus a sub n minus 1 times x raised to n minus 1 plus a sub n minus 2 times x raised to n minus 2 plus a sub 1 times x plus a sub 0. Now, a polynomial is an expression that consists of terms connected by addition or subtraction. So, we have a sub n times x sub n, that is the first term. A sub n minus 1 times x raised to n minus 1, that is our second term. And a sub n minus 2 times x raised to n minus 2, so that is our third term. And a sub 0, that is our last term. Now remember, polynomial expression, each term has a variable raised to a power. That is a natural number. So let's have an example. 5 plus 3x minus 4x squared plus x cubed. It must be also in standard form of a polynomial. It has written by decreasing order of degree. So for number 1, 5 plus 3x minus 4x squared plus x cubed, when you arrange them in standard form, you have x cubed minus 4x squared plus 3x plus 5. And then, what about x squared plus 5x raised to 7 minus 5? So, when it is written in standard form, you have 5x raised to 7 plus x squared minus 5. Which is a polynomial expression? Is it number 1, number 2, number 3, or number 4? To be considered as a polynomial expression, we have number 1, it must contain no radical variables. So look at number 1, 3x raised to 5 minus square root of x raised to 4 minus x raised to 1/3 minus 6. Now since it has a square root of x raised to 4, so therefore number 1 is not a polynomial expression. Number 2, there should be no rational or negative powers on the variables. Now, if you are going to look at number 2, so there is a negative power, which is x raised to negative 3. So, therefore, number 2 is not a polynomial expression. Okay, next, what about another? So, look at number 3. No variables in the denominators of any fraction. So, there is a variable for number 3. So, the denominator is x minus 6. So, the variable is x. So, it is not allowed. So, therefore, number 3 is not a polynomial expression. Now, again, number 1, number 2, and number 3 are not a polynomial expression because they have a radical variables, rational exponent, negative powers, and the denominator has a variable. So therefore, the polynomial expression is number 4, which is 3x raised to 5 minus x raised to 4 plus 6. Let us talk about division of polynomials. Let's have long division method. Divide 25 plus x squared by x plus 2. Now, 25 plus x squared is our dividend and x plus 2 is our divisor. Now, let's write in standard form. The standard form of 25 plus x squared is x squared plus 0x plus 25. take note that 0x is missing, or x raised to 1 is missing, so we replace it with 0x. Then, let's divide. X squared divided by x plus 2, we have x. Then multiply the partial quotient x to x plus 2. So x times x, we have x squared, and x times 2, we have 2x. And then subtract. X squared minus x squared is equal to 0, and 0 minus 2x is equal to negative 2x. And then bring down 25. Next, divide negative 2x plus 25 by x plus 2. So negative 2x divided by x, you have negative 2. And then again, multiply negative 2 times x plus 2. So we have negative 2 times x, you have negative 2x. And negative 2 times 2, you have negative 4. And then subtract. Now, negative 2x minus negative 2x, you have 0. 25 minus negative 4, you have 29. So, x minus 2 is our quotient, and 29 is our remainder. Now, our final answer is x minus 2 plus 29 over x plus 2. Let's have some activity. Find me and you will see. Divide each polynomial using long division. Find the correct quotient of each number and put the letter in the box that corresponds to the number. So number 1, you have x squared minus x minus 30 divided by x minus 6. Number 2, you have x squared minus 4x plus 4 divided by x minus 3. Number 3, you have x squared plus 8x plus 16 divided by x plus 4. And number 4, you have x squared plus 9 divided by x plus 3. And number 5, you have x squared plus 12x plus 36 divided by x plus 6. And number 6, you have x squared plus 5x minus 14 divided by x plus 7. And number 7, you have 2x squared minus 5x minus 7 divided by x plus 1. And number 8, you have 4x squared minus 3x minus 10 divided by x minus 2. And number 9, you have 5x squared plus 20x minus 25 divided by x plus 5. So what is the answer? Now you may check your answer if they are correct. So the given answer for number 1, the answer is x plus 5. For number 2, the answer is x minus 1 plus 1 over x minus 3. Number 3, the answer is x plus 4. And number 4, the answer is x minus 3 plus 18 over x plus 3. For number 5, the answer is x plus 6. For number 6, the answer is x minus 2. For number 7, the answer is 2x minus 7. For number 8, the answer is 4x plus 5. And for number 9, the answer is 5x minus 5. Thank you. I hope you have learned something about our lesson. You remember about factoring, polynomial expression, and dividing using long division.